Hello everybody and welcome to this presentation. My name is Maysam Gordon. I'm a PhD from University of Malaya. Today, I'm going to talk about a decade of research in structural health monitoring based artificial intelligence in the Department of Civil Engineering at UM. It should be noted that I'm also contributing in research and development with PASOFAL Engineering Group, which is a research and development center. More information about PASOFAL is available on our website. Structures can be subjected to damage induced by different causes such as fatigue, aging, earthquake, wind excitation, and overloading. That's why we need to diagnose the state of the material, different parts, and the whole structure at every moment during service life of the structure. So, aims of SHM are to determine the current condition, to predict the future behavior, and to early detect the structural damages using 4 levels, including existence of a damage, location and severity of a damage, and prediction the service life of the structure. SHM systems can be used in different engineering assets such as bridges, dams, railways, tunnels, pipelines, transmission towers, and buildings. SHM systems help to reduce the maintenance, improve safety, and increase the health of structures. SHM systems are extremely similar to human nervous systems. Current SHM methods have many limitations. For example, they are labor-intensive, costly, time-consuming, and based on human judgment. Therefore, emerging technologies such as Internet of Things, artificial intelligence, and data mining can improve the accuracy of SHM systems. To this end, advanced data analysis technologies need to be applied for reported data obtained from structures. Data mining methods include artificial intelligence such as artificial neural network, fuzzy logic, and meta-heuristics. Machine learning such as super-vector machine and principal component analysis. Statistical methods such as decision tree, regression analysis, and clustering. Data mining can be compared to gold mining in rivers. The term gold mining refers to the search for gold in rocks or sand. Data mining is also a search for information and knowledge. Data mining has several languages to run, such as Beka, SPSS Statistics, IBM SPSS Modeler, MATLAB, C++, and so on. Data mining has different functions such as prediction, clustering, visualization, and summarization. The Department of Civil Engineering is one of the first academic departments set up under the Faculty of Engineering at UM. In recent years, a number of innovative researches have been carried out in a structural health monitoring research group and advanced shock and vibration research group using AI. So, we used different computational techniques such as data mining, ANN, fuzzy logic, genetic algorithm, imperial competitive algorithm, super-vector machine, decision tree, and regression in 2 different types of civil structures such as basic structural components and complex structural systems. For example, a fault diagnosis approach on beam-like structures using ANN was developed by Dr. Hakim. The principal advantages and benefits of using ANN in structural health monitoring was explained by him. An ANPIS-based damage detection approach was also developed for damage localization and severity prediction of beam-like structures using vibration characteristics. A hybrid approach using wavelet analysis and genetic algorithm was developed by Dr. Ravanfar as a damage detection system. The GA estimated the damage severities at the identified locations by introducing a database obtained from a three-story building model. It was concluded that the implementation of GA could solve the problem of wavelet-based damage detection methods. Another wavelet-based method using GA was also developed to solve inverse problems. Dr. Mahdavi reported that the procedure of structural identification could be improved by the proposed wavelet-based GA strategy through testing three structural models, such as a 2D truss structure, a 4-story shear building, and a shear structure. A damage detection method based on the frequency shifts of the updated finite element model and their relationship with the experimental data using multiple linear regression analysis was proposed by Dr. Monajemi. A jacket platform structure was fabricated and tested to generate a database. Dr. Monajemi reported that the multiple regression analysis was a reliable algorithm to identify the damaged member. Dr. Tan from Queensland University of Technology and we built a scaled model of a multiple composite slab-on-girder bridge in heavy structural lab at I have implemented a series of experimental modal analysis in undamaged and damaged states which took 2 years' time. I generated a database from several inverse analyses using the first 4 modes of the structure. Then, Dr. Tan used the database in her research using different methods such as ANN. And I used the database in data mining-based damage detection using ANN, supervector machine, classification and regression tree, and a hybrid ANN-based imperial competitive algorithm method. I used a generalized form of cross-industry standard process for data mining in a structural damage identification. The results obtained from 4 patterns showed that the AI algorithm could provide the best performance in compared to the statistical and machine learning methods. This makes sense due to the fact that artificial intelligence techniques have the highest application rate in SHM due to their accuracy, flexibility, and optimization capacity. Our team published more than 20 ISI papers in high-quality journals from 2013 until 2020. For example, I published my works in Applied Soft Computing and Measurement. We also published our articles in peer-reviewed journals, international conferences, and book chapter. In conclusion, a number of SHM-based theoretical and experimental investigations were conducted in our department using basic structural components and complex structural systems. The application of ANN was the most common SHM-based soft computing algorithm in our groups due to the high computational ability. And among all optimization-based meta-heuristic algorithms, genetic algorithm, and imperial competitive algorithm well applied for damage detection of structures due to their convergent performance. In the end, we would like to express our sincerest gratitude and appreciation to Professor Emeritus Hashim Abdulrazak as a PI of presented projects and all parties who participated directly or indirectly. Thank you for your time and attention, and I appreciate that I've had this opportunity to present our research topics. If you have any question, please leave your message below. We will get back to you shortly. Thank you.